NASA's insane plan to reach an alien ocean. Imagine lowering a camera into an ocean no human has ever seen. No sunlight, no sky, no waves breaking against a shore, just endless black water beneath an alien world. And somewhere inside that darkness, something may be alive. This ocean is not on Earth. It is not on Mars. It is hidden beneath a massive shell of ice on Europa, one of Jupiter's moons. NASA is developing technology that could one day break through that ice and enter the ocean below. Not just photograph it from space, not just scan it with radar, actually go inside. Because beneath Europa's frozen surface may be one of the best places in the solar system to search for extraterrestrial life. From a distance, Europa looks almost smooth, a bright frozen moon covered in enormous reddish cracks, but close up, the surface becomes much stranger. Long ridges cut across the ice. Huge shattered regions appear to have broken apart, rotated, and frozen again. Some areas are called chaos terrain because the surface looks as if something underneath disturbed it. And that may be exactly what happened. Scientists believe Europa is hiding a global ocean beneath its icy shell, an ocean that may contain more water than all of Earth's oceans combined. No camera has ever seen it directly, but the clues are powerful. Europa's magnetic behavior suggests a salty, electrically conductive liquid layer beneath the ice. Its cracked landscape appears shaped by movement inside the shell, and Jupiter's gravity constantly stretches and squeezes the moon. This is called tidal flexing. That flexing creates heat inside Europa, possibly helping keep the hidden ocean liquid. That is why Europa matters. Life as we understand it needs three things: liquid water, the right chemistry, and a usable source of energy. Europa may have all three. The ocean provides water. The rocky interior could provide minerals and chemical reactions, and tidal heating may provide energy. On Earth, life survives beneath glaciers, inside rocks, and around hydrothermal vents where sunlight never reaches. So life on Europa would not need forests. It would not need air. It might not even need sunlight. The first discovery would probably be tiny, microbes, but even one alien microbe would change human history. There is one huge problem. Europa's ocean is almost impossible to reach. First, there is Jupiter. Jupiter has one of the most powerful radiation environments in the solar system. Europa orbits directly through it. Its surface is blasted by high-energy particles that can damage electronics and destroy biological material. A robot would need heavy shielding just to survive. Then there is the cold. Europa's surface can fall below -150°C. At those temperatures, materials become brittle, batteries lose performance, and machines can freeze or fracture. And beneath that frozen surface is the greatest obstacle: the ice. Scientists are still working out exactly how thick Europa's outer shell is, but in many places, it may extend for tens of kilometers. That is not a frozen lake. It is a wall of ice deeper than Mount Everest is tall. No spacecraft has ever drilled anywhere close to that depth on another world. Before humanity can reach the ocean, it has to understand Europa. That is the job of Europa Clipper. NASA has already launched the spacecraft and it is traveling toward Jupiter. Europa Clipper will not land. Instead, it will orbit Jupiter and fly past Europa again and again. Its cameras will map the surface. Its instruments will study the ice, gravity, magnetic field, and particles around the moon. Radar will investigate structures beneath the surface. Clipper will also search for possible plumes. If Europa is spraying icy material into space, those plumes could give scientists a shortcut. Europa may be throwing samples of itself into space. But Clipper is only the scout. The next major step would be landing. A future lander could collect surface samples and search for organic compounds, but radiation damages Europa's uppermost ice, so a lander may need to scrape or drill beneath the damaged layer to reach better preserved material. Even that would be extremely difficult, but it would still be nothing compared with reaching the ocean itself. For that, scientists have imagined a machine called a cryobot. A cryobot is a robotic probe designed to travel downward through ice. It would not work like a normal rotating drill. Instead, it could use a powerful heat source to melt the ice beneath it. As the ice melts, the probe slowly sinks, meter by meter, day after day, possibly for months or even years. It would need to survive pressure, avoid refreezing, and move through cracks, salts, and dirty ice layers. Above it, a lander would remain on Europa's surface. The cryobot might stay connected by a long cable carrying power, commands, and data, but that cable could snap. It could freeze into the ice. It could be crushed as the ice shifts. So engineers have also studied wireless relay systems. Imagine breadcrumbs left behind inside the ice. The cryobot sends data through the relay network. The lander sends it to a spacecraft above Europa. And that spacecraft sends the signal hundreds of millions of kilometers back to Earth. Every link must work. There is another serious danger: contamination. Any spacecraft built on Earth can carry microbes. Some can hide inside tiny cracks. Some can survive extreme cold and radiation. If a cryobot entered Europa's ocean carrying Earth organisms, it could contaminate a world isolated for billions of years. Then if the robot detected bacteria, were they alien? Or did they come from us? That is why planetary protection would be one of the most important parts of the mission. If the cryobot finally reaches the bottom of the ice, the mission enters a completely new phase. The probe breaks through into a dark alien sea. For the first time, a machine from Earth enters an ocean on another world. It releases a small autonomous underwater robot. Its lights switch on, its cameras activate, and it begins exploring water that has never touched Earth's atmosphere or sunlight. The underwater robot could measure temperature, salinity, and pressure. It could search for organic molecules. It could study minerals and chemical energy sources. It could look for patterns that are difficult to explain without biology. Maybe it would find methane, maybe complex organic compounds, maybe structures resembling cells, or maybe it would find nothing alive at all. Even that would matter. It would teach us why some habitable environments remain empty. The most exciting possibility is deeper down. Europa may have hydrothermal vents on its seafloor. On Earth, similar vents support life without sunlight. Microbes feed on chemical energy. Larger organisms feed on those microbes. Life flourishes in total darkness. Europa could have its own version of that hidden world, but reaching the seafloor could mean traveling through an ocean more than 100 kilometers deep. No GPS, no sunlight, no direct control from Earth. The robot would need to recognize hazards, choose routes, and protect itself alone. Right now, no full mission to melt through Europa's ice and enter its ocean has been approved. The cryobot remains a future concept. Scientists and engineers are still developing the technology, power systems, ice-penetrating hardware, radiation protection, sterilization methods, underwater navigation, communication through kilometers of ice. A mission like this could still be decades away, but Europa Clipper is bringing humanity closer. One day, humanity may land on a frozen moon beside the largest planet in the solar system. We may switch on a machine built to survive radiation, cold, and crushing pressure. We may begin melting downward, through ancient ice, past layers untouched for millions of years, deeper than any spacecraft has traveled beneath another world, until finally the ice ends, and the ocean begins. A robot opens its eyes inside an alien sea. Its lights cut through the darkness. Its instruments begin collecting data. And on Earth, humanity waits for the signal. Maybe Europa's ocean is empty. Maybe it contains only chemistry and water. Or maybe, hidden beneath kilometers of ice, life has been surviving there for billions of years, quietly, completely separated from Earth, waiting for us to find it. And if we do, we will finally know that life is not something that happened only once. It is something the universe can do. I'm Astro Artemis. Stay curious, crew.